Hi, everyone. Thank you for being here. Today I'll be sharing some of our experiences with going 100% with Kotlin and Anko on an Android app. So I'll be live tweeting some key takeaways from this talk, but first of all, who am I? So my name is Gonçalo. I work at Todoist, where we build products like Todoist. And we've been building apps for wearables ever since, basically, wearables were available. We have an Android Wear app, we have an Apple Watch app, which is now in its third iteration. And Android Wear 2.0 will come out near the end of the year. And just like the Apple Watch, Google is promoting fully standalone apps, in this case, that work with both Android devices and iPhones. So obviously, we're jumping on this train and building the new version of the Todoist app that's not only an extension of the mobile app, but also a fully standalone app in itself. So which one of you has built apps for wearables? All right. So those of you that haven't, you should know that besides the difficulties that you have with smaller form factors and smaller batteries, you also get like really underpowered components like CPUs, RAM, disks. They are much, much slower than the mobile counterparts. So despite this, both Apple and Google are pushing for fully standalone apps, which creates some really interesting challenges. First, even though you can share most of the backend logic between your mobile app and your wearable app, so your syncing, your storage, you can share most of this stuff, you will need to build completely new UIs, so it is effectively a new client. Second, if you are working with Android Wear and you're starting a new app right now, you have to think, do you have to go with Java? As you know, in Android, Java is stuck in a 6.5-ish thing where it's basically Java 6 with a few Java 7 features, and now with the latest couple of versions, you also get a few Java 8 features. It's not really 100%able with any Java version except Java 6. And although you can fix most limitations with backports, like retro lambda and many others, I could just start building a list, you will still bump into many restrictions and some problems with the Java APIs, and also the Android APIs themselves. So the first thing that sometimes creates a few problems in the Android APIs are that there's inheritance everywhere. Also, Android APIs work a lot with null, because null is a very efficient way to signal that there is no value. And this helps a lot Android's garbage collection, but it creates some difficult challenges for code quality and structure. And finally, there's a lot of boilerplates in Java and Android APIs. There's boilerplates everywhere. So we basically thought, OK, we're starting a new app. It's 2016. Let's look for alternatives. What can we use from what's out there? And specifically, we looked at 4 characteristics. So we wanted a language that was modern. This means that it's a concise language. It's a safe language. It has a great handling of optionals and allows for great functional programming. We wanted a language that was fast, so pretty much as fast as Java or very, very close, both at startup and runtime, because we don't want a language that's fast when you're using the app, but that takes multiple seconds to start your application just because you're using it. Also, again, wearables, underpowered CPUs, this is even more of a problem. And also, wearables, you use them in micro interactions, so they need to be really fast. We also wanted a language that was small. So Android is used by 85% of smartphone users around the world. And many of these users are in third world countries where mobile data is, more expensive than gold here. So if your APK has 3 or 4 megabytes more just because of a fancy language that you use, people in Africa, they will notice this. People in many places around the world will notice this. So we want something that's small, that has a small footprint on our APK. At the same time, when you add big libraries to your application, you get near the 65,000 method limit that Android has for APK. So of course, you can work around this with multidex, but multidex makes, again, app startup slow. So we go back to point 2, it's slower. And so we pretty much want a small footprint in method count and size. And finally, we wanted a language that was highly interoperable. So using it from Java and using Java from it in idiomatic ways should be seamless and like not create difficulties without obviously incurring in penalties. So the first language we looked into was Scala. Now Scala obviously in JVM languages is the pinnacle of modern languages. It has all the bells and whistles I've been talking about so far. So definitely modern. However, although it's pretty much as fast as Java at runtime, it adds 50,000 methods to your code. So suddenly, you didn't write any code, and you're at the 65K method ceiling. Boom, multidex is coming, your startup is slow, and this is something that you shouldn't ignore. And since it has 50,000 methods, just with its standard library, it's not small at all. It's 6 megabytes. You can use stripping tools like ProGuard in production that help with this. They cut off the code you don't use, so the APK becomes smaller. But again, if you're really committing to writing a full app in Scala, you're probably using a lot of things from their standard library, and ProGuard won't do like magic. There are no miracles. And Scala is pretty interoperable with Java when you're accessing Java from Scala. The other way around, although, for simple code, it's fairly trivial. But if you're using Scala to its fullest potential, so if you're using operators, polymorphism, and stuff like that, it becomes tricky. So it's possible, but it's tricky. So then we looked at Clojure. And just like Scala, Clojure is a pretty modern language. It focuses heavily on functional programming, which is interesting, has first-class functions, it has a great support for immutable data, and so on. However, it is not fast at all on Android. Like startup on apps using Clojure usually takes multiple seconds because they do some fancy stuff with their standard library on startup. It's a big penalty on Android. On wearables, obviously, this shows up even more. And although all that great functional programming and first-class functions, it actually puts some pressure on Android's garbage collector because it does a lot of allocations you're not expecting it to do when converting to bytecode that Dalvik and Art understand. So it's also rather huge. It has 16,000 methods and amounts to 4 megabytes on your APK. Again, you can use ProGuard, but there are no miracles. And interoperability is really not great. I mean, accessing Java from Clojure is trivial, but the other way around pretty much uses reflection for almost everything, so it's significantly slow in the Android's VMs. And so in general, for us, it's just a big no. We also looked at Groovy, which is obviously modern. It's also used by Android's build system, like Gradle, so it's a familiar language, you've already seen it. But unfortunately, it's also a big no in terms of performance. So we didn't dig too much into this ourselves. We just saw an article from the New York Times from about 6 months ago where they basically had a lot of performance complaints on startup. And they profiled this for a few days, and they eventually narrowed it down to the usage of Groovy in their app, which once they removed, they got like 10-fold better results, and the complaints were gone. It's also quite large. It adds almost 30,000 methods and 5 megabytes to your APK. And finally, interoperability is actually pretty nice. It works well, as you would expect. It's mostly nice to use. So for completeness, and because people on Twitter and in blog posts, they like to talk about Swift on Android, but the thing is, it makes no sense. Let's please quit this discussion. Android has APIs that were built over 10 years on top of Java, and I don't see Google building in 1, 2, or even 3 years the same APIs from the ground up for an LLVM language. Swift can't be used in any sane way on Android right now, and I doubt it will become a sane option in the foreseeable future. So, to end this, we also took a sneak peek at future Java versions. So Java 9 will bring a bunch of cool things, and so is Java 10. It has classes, it has optionals, and a bunch of other things which make it a much more modern programming language. But the thing is, we'll all be dead when Android supports Java 10. So this is the first goal of my talk. I will try to convince you that if you're starting an app now, or if you're making some big refactoring to your code base, you should definitely switch to Kotlin if you're programming for Android. So does any of you has used Kotlin in the past or is using? OK, so basically, Kotlin ticks all the right boxes. And since only 3 people have used Kotlin in the past, and because I already have this in my slides, I'm going to do like a very quick tour on the syntax. So can you guys read this? More or less? OK. So this is a class in Kotlin, a purchase class with 2 properties, value and success. The primary constructor is here declared. It receives 2 arguments that we set on the class properties. Now, since this class constructor has no visibility modifiers or annotations, we can actually make this much more concise. We basically don't need the constructor keyword. We can declare class properties directly in the constructor, so this becomes a class property. Purchase now has a property called value. And also, if you want to make this a data class, so you get getters, setters, equals, hashcode, copy, toString for free, you just prepend the data keyword at the beginning, just like this. So let's add another class to our example. This data class is a customer. This customer has a name and a list of purchases. And let's add a singleton. So this is a big no, don't do this, but this makes my example work. So we have a singleton that has a list of customers, and this is like our data set. You can also see in this example that we have an init block. So this is not a constructor. This is an initializer. It runs right after the constructor and has access to all the parameters that you pass in, although there are not any in this case. So this is a function that retrieves all successful purchases for a specific customer. Now, this is a lot of code, and this is freaking boring. But this is how you would do it in Java, kind of, if you wanted this. So you have a function. This is the fun keyword that you use to declare functions. You name the function. Another difference from Java is that the parameter types, or they come after their name, and the return types also come after the declaration, both using a colon. Here you can see that Kotlin has values and variables. Values are basically immutable. If you search for this online, you will see a blog post saying that values in Kotlin are not really immutable. But to simplify, think about them this way. This means that I am assigning successful purchases to a new array list, and I can't change this in this block code, although customer can be changed. And in fact, we're going to loop over the current customers to try to find it. So we need to initialize it as null. It's going to change. Another cool thing about Kotlin is this question mark. So basically, all the data types in Kotlin, they cannot be nullable unless they are appended by this. So when you have a mutable list of purchases here, successful purchases will never be null, and the whole code knows about this. So then, to find the successful purchases of a given customer, we iterate the customers in our data set, we look for the customer, and we assign it. Basically, this for-if workflow is pretty similar to Java. The only thing to note is that this operator equals equals is actually doing the Java equals function call, so it's not comparing references. In Kotlin, you have to use 3 equal signs for that. This makes way more sense. Then, if we found the customer, we iterate their purchases, and if the purchase was successful, we add it to the list we're going to return. One last detail about this block of code is that Kotlin is smart. So it's smart when it comes to casting. It's smart when it comes to nulls. So you just checked that the customer was not null. And this means that inside this whole block, the language knows that the customer is not null. So suddenly, it's not a customer question mark. It's just a customer. It's the same thing when you check if an object is an instance of a type. Inside that if block, that object is the instance of that type. So no casting, no dumb stuff. So this is not idiomatic at all. Like, this is not really Kotlin. So the very first thing you can do is use higher order functions to just start trimming away useless code. So you can use the find function, which takes a block. and basically finds the customer you want. So this removes a whole loop for us. And then if you have a customer, you can use the filter higher order function by success. So if you're acquainted with functional programming, this will make a lot of sense. And suddenly, this function is much easier to digest. As usual, you can go overboard. You can pretty much make this a one-liner. If any of you has ever worked with Ruby, you know this is a thing. So I have worked with Ruby in the past, so I tend to always try to do this. And this does exactly the same thing as our initial function. The reason I have this here is because there's some cool things about handling nulls in Kotlin, which I'm really a fan of. Namely, the safe call operator. What this does is, basically, if you find a customer, it gets its purchases, its property on purchases. But if you don't find the customer, so if this returns null, it basically stops executing from here. It just returns null. So you do the same thing here, and basically this whole block will automatically return null if no customer is found. And then we have this question mark colon symbol, which is called the Elvis operator, because it kind of looks like Elvis. What it does is, if the left-hand side, so the whole thing we called before, is null, it just returns the right-hand side. So if there is no customer, this whole thing goes to null, and we return an empty list. It's just like that. So this is our one-liner, which, since it's just a single expression, this can even not be a function. This can become a function expression, so we use the equal sign, and this pretty much works. Now, one thing I'd like to highlight is that this part is kind of messy, the Elvis operator in the end, but it's basically because our return type is a list of purchases which can't be null. Now let's assume that we can relax this constraint and say, okay, if there is no customer, just return null. There is like no list of purchases. Then the function becomes like even easier to understand because we can just remove the Elvis operator from it by just adding a question mark here. So one of the really, really cool things, actually before I move on, like this whole null handling actually makes dealing with nulls in Android much easier. As you know, nulls in Java are called like the billion-dollar mistake. They are the root cause of most bugs. And actually, Kotlin is very explicit about the way you're working with nulls, when things can be null, when they can't, when they should, etc. And they have operators to deal with this complexity. So moving on, Kotlin has the ability to extend classes that are out of your control. So let's assume for a moment that we didn't control the customer class that we just created, but we wanted to add the successful purchases method to it. So in Kotlin, we just declare the function just like before, but we add the customer dot before its name. So function in customer called successful purchases, which does this. It filters the purchases property by success. This is added to the customer class. So for example, purchases here is its own property of purchases. The way Kotlin really does this is via a static method call, but for you, while coding, it's just like it became part of the API of that class. So when you have a specific customer and you call the successful purchases method from it, you'll get a list of purchases. So let's recap for a minute and think that we started with a code that looked like this. This is pretty idiomatic in Java, unfortunately, and we ended with something like this. So this is pretty much to illustrate how great Kotlin's syntax is when it comes to nulls, higher order functions, and null handling, optional handling. Of course, like I just focused on these three aspects because I feel like they're some of the most important, but Kotlin brings a ton of stuff to the table, including JavaScript support, which they are improving. So Kotlin is you're able to code once for your Android client or your backend Java server, and also like get JavaScript for the front end. All right, so Kotlin is modern, but is it fast? So Kotlin just generates bytecode, basically. And it's a pretty straightforward, statically typed bytecode. The way it improves its interoperability with Java is that it generates like Java classes that are not really used for the final build, but they allow you to use Kotlin just like a normal Java code. Also, so its performance is pretty much on par with Java. In fact, in some cases, like inline lambdas, it's better because what's available on Android right now, when you target like newer devices, which it's not really realistic, you can use lambdas, but actually Android does allocations and virtual method invocation, which is kind of costly, while Kotlin just inlines your lambda calls. So basically, and JetBrains is actually actively monitoring Kotlin's performance on every release, and they have a set of benchmarks that cover a bunch of things, and they are updated on every release. So basically, Kotlin is fast. But how small is it? Well, Kotlin is basically, its standard library is basically 5,000 methods, so it's like 4 times smaller than the smallest of the other alternatives, and it's getting smaller on every release thus far. It adds about 1 megabyte, a little less than 1 megabyte to your APK. And as I said, since the first release until now, there was never a major Kotlin release where it went up. It's coming down. So it's small, and how interoperable is it? So as I hinted before, it's 100% interoperable. You can easily use idiomatic Kotlin from idiomatic Java. And you have annotations for customization. Because since Kotlin has some pretty cool features, for example, you can define multiple classes in the same file. Obviously, this is not supported by Java. So it has some defaults for generating the Java equivalents that you can use. But you can customize its behavior using annotations if you don't like the defaults, which are generally pretty sane. So Kotlin has all of this, and we feel very confidently that it's the future of Android programming. It's a shame that Google is not officially backing this because it brings all the bells and whistles with pretty much no trade-offs. So let's talk about one bonus point about Kotlin. Android APIs can be a pain. They can be inconsistent. They can lack features. There is a ton of ceremony everywhere. And if you have developed for Android before, when you have a rather bigger project, you have a util package with 50 things, like view utils, bitmap utils everywhere. It's a freaking nightmare. But remember how I talked about extension functions? Well, you can use Kotlin to extend pretty much the framework classes. So look at this workflow. This workflow is one of the great examples of the ceremony in Android APIs. So this is basically how you make a change to your database wrapped in a transaction. You need to manage a try finally block. You need to begin a transaction, set it successful, and end the transaction. And if you look in your code, you're going to repeat this many times. Or you have a util class, one of the two. So with Kotlin extension functions, we can pretty much make this part of the database's API. So again, we declare a function on the SQLite database called inTransaction that handles all the ceremony for us. And the goal is that in your own code, you only have to worry about the change you're going to make to the database. So one thing to note here, we're using the inline keyword while extending. This tells Kotlin to inline the code you're running on every single invocation of that method. This makes functional programming very efficient. And one crazy, geeky thing I just want to highlight is that if you remember the previous code, you opened the block in transaction, and you didn't have to use the it keyword to work on the database. The reason is that you're saying that the inTransaction method takes a parameter, which itself is a member function of the object passed in. So in that context, it already knows the context in which it is executing. So this is kind of hard to explain. I hope it made some sense. If not, Kotlin has here. Basically, there's no it. Kotlin has Kotlin cones, which are small examples of Kotlin code and showing all the features. It's available on their website, and it's pretty cool, and I recommend that you spend a couple of hours doing. You can pretty much do all of them, and it shows off stuff like this. So here we go. A much saner, non-duplicated, and easy way of dealing with the database. But this is not a single example. Like Android's APIs are full of things that make no sense. For example, when you're dealing with cursors, get int, get byte, whatever, if your column in the database is nullable, you have to manually check for null in every single interaction you have with it. Otherwise, it can crash. So you have, if this column is null, your member variable or whatever is null, otherwise read from it. So you can just add a method to cursor like getString or null that does this in a neatly tagged package. Similarly, if you're working with paddings on views, it's freaking annoying that you cannot set the padding of one direction only without setting all others. So your code will be riddled with view, set padding, get padding top, get padding left, get padding right, and finally the padding you want to change at the bottom. Again, you can extend the view class and add a specific method to handle this for you and hide the API, the poor decisions in the API from you. And you can go even further. You can add a method to the view class to generate a bitmap from its content. This is a scenario that's not so common, but at least in our products, we use this a lot. So instead of having a utility class, we can just add it to the view class, and then it's a one-line method call to it. So these are just a few examples of how you can use Kotlin to make the Android APIs work for you and not against you. There's a bunch more that I could have done, especially around Google Play Services. If you've ever used it, you know how painful it can be. Kotlin is amazing to fix all of that stuff. So in conclusion, from the investigation we did in the beginning and from our experience of using Kotlin thus far, it ticks all the right boxes. It's 2016. There's really no excuse for using any other stuff for Android development. So my talk also mentioned Anko. For no reason in particular. Anko is something we discovered while we were investigating Kotlin. And basically, Anko is a Kotlin DSL that aims to fix the many, many problems that you have when declaring layouts in XML for Android. Namely that it's not type safe, it's not null safe. Although it is converted to kind of a binary format during compilation, you still have to parse it at runtime and waste CPU cycles with it. And reusing code while declaring Android views is possible, but it's kind of hard. So Anko aims to fix some of these problems by basically looking like this. Again, a Kotlin DSL. In this case, we have a vertical layout. It has a name, which is an edit text that we're assigning to a variable. It has a button with a text that when you click, it shows you a message. So basically, if you were doing this in XML, you would have around 80 lines, and you would need some Java code to bind, to make the print message call. So Kotlin tries to be concise. It's one of their goals. And basically, the way you use it to declare layouts is that you include the Anko block at the end of your onCreate in case of activities, or onCreate view in case of fragments. You include your logic there. And it's also trivial to reuse portions of your layout. So for example, I'm going to skip a slide to help out. You see that our activity layout that it's coming up, it has two input fields that we want them to look exactly the same way. So basically, what we do is declare an input field method on the linear layout that, it has a text view. You specify exactly how it looks, the text size, the margins, etc. And then you use it more than once without duplicating the logic or having to assign styles more than once, and etc. So this is one of the ways that they approach layout deduplication. So basically, Kotlin is a DSL, again, but it's also more than a DSL. So they have a bunch of utilities for threading, for dealing with the database, intents, meaning you call other apps and back and forth, and a bunch of stuff. Like their lists of things that that they make Android better is huge. However, unlike Kotlin, we're not fully convinced that this is the way to go, no exceptions. It has a few problems. So the number one problem, which I don't talk about it here because it's kind of a personal opinion, is that it does too much. So Kotlin went overboard. It was a DSL for layout, and suddenly it has helpers for every single thing you might want in Android. And it lacks some focus on the things it wants to do really well. Also, as you saw, while you can have the discipline of not doing this, like mixing business logic with UI, Kotlin makes it so easy. You saw how we were defining our layouts and the click listener logic inside of it. So this is so easy with Anko that you might end up doing it, maybe even out of convenience. While with XML, you're pretty much out of luck because it's not possible, it's not dynamic. Another problem we've had is that it's limited to the Java API, View API. So again, the Android APIs are so amazing that there are a few properties that you can use from XML but not from Java because there is no setter or equivalent. Anko is creating the views at runtime using the Java APIs. So if there's something missing from the Java APIs, you're out of luck, you can't use it. And at the time, it does not support themes for Android. Themes have been out on Android for about more than 2 years now. The new version of Anko will support this, but I mean, it's still not here. But we're going with Anko for our Android Wear app because it is freaking fast. So on average, it's twice as fast as declaring the same layouts in XML. In our tests, it can go up to even 3 times faster, depending on the complexity of your layouts. I should mention that we actually measure this on wearables. So, you know, crappy CPUs doing all the work where these differences are more noticeable for you as a developer and also for the user while using your app. And this is like the average. I'm comparing this obviously to normal layout inflation, so declaring XML and inflating it. So basically, so far, these are our conclusions. Like, use Kotlin now, and Anko, you know, check it out. It might make sense for you in your context. Maybe your #1 requirement is speed, like us, so you accept the trade-offs and you go with it. So that's it. Thank you for coming. The slides are available. Questions?
Hi. I wanted to ask you about immutable vals. You mentioned that they weren't really immutable. You mentioned the vals weren't really immutable.
Yeah.
Could you explain a bit?
Have you used Kotlin before?
Scala developer here. We can talk about that later if you want.
I think it's best because this we can delve into, like, this is actually going into hardcore Kotlin, and there are some edge cases where you can change values because of the way they are built. Like, okay. So, but I'll get back. Wait for me outside. Okay. I'll show you.
Another question was about the extension methods.
Yeah.
What's the semantics and then about a conflict? So if you write an extension method and someone else writes the same with the same name, what happens? Thanks.
You'll get a. So okay. So the question was, if you declare the same extension method twice, which one takes precedence, right? Okay. So this actually is also possible in another more common scenario, which is you have multiple inheritance in Kotlin, although there is kind of this system where it's clearly visible what takes precedence. Like in the specific example of extension methods, they have multiple visibilities. So you can have an extension method that's only available inside the current file, the current package, etc. But of course, you can make it public, so all of your project sees this extension method. And you can make this more than once. And this will result in a compilation error. Inheritance is kind of different, though. It depends on the order in which you declare things, basically. It's the usual approach to it.
So if you import a Java library to a Kotlin project, does all the return types become nullable, or do you expect them to have an annotation, or how does it deal with that?
So if you import a Java library and you use it from Kotlin, it's actually really trivial. Since in Java, by default, all the types except primitives can be null, they just become the equivalent in Kotlin with a question mark. And you need to handle null explicitly. So that's the cool thing about Kotlin, is that since these types can be nullable, you have to deal with it. You cannot just ignore them like we do so many times in Java where we say, oh, this long object can never be null. So you just go ahead and you use it like a boss, and one day it crashes because for some reason it ended up being null. In Kotlin, this is impossible, you know? So when you're using Java libraries, basically that don't support this, they get automatically converted to the question mark variant. Now, I should add that JetBrains, Android itself, they have a specific set of default annotations when you want to annotate stuff that cannot be null. So you have the non-null annotation to tell clients of your API or library that that value will never be null. Well, Kotlin is smart enough about this to understand these annotations as well. So if your library uses any of these annotations, it will be, Kotlin will be smart about it.
Okay, thank you.
Hi. So my question is, can you automate, can you do UI testing with Kotlin and Anko or?
Not yet.
Not
we
yet.
want to, but like, as you know, Anko, like the Android Wear 2.0, which was what started all of this revolution for us, was announced, I don't know, 3 months ago. So we had a few days of exploration, and since then we've been developing, but we haven't delved into automated UI testing using both of
So
these.
Express and UI Automator are not compatible with Anko and
Sorry, I didn't understand.
Espresso and UI Automator are not compatible with Kotlin and
Why wouldn't it be? It's a runtime thing. You find IDs.
yeah, that's why I was asking, because I noticed that in Anko you don't have IDs.
Oh, you can have IDs.
You can.
Yeah.
Oh.
My examples don't have them, but yes, you can specify the ID of all your views in Anko.
Okay, so UI Automator, for example, I think you can use it.
What's
UI Automator, I think you can use UI Automator.
Yeah, we can automate it. I was just like replying directly to the question, like we are not automating right now. So we plan to, though. We use this on the mobile app, so we want to have the same testing approach to the wearable app. Okay, guys, have a great day.